Mod flow array data such as layer elevations, starting heads, and hydraulic conductivity can be defined by interpolating from 2D scatter points. The same tools that are used for 2D and 3D geostatistics are used to interpolate to mod flow arrays. We will open an existing file containing a 3D grid and some scatter point sets. Selecting a cell in the middle of the grid, then moving to the front view allows us to see the interior of the layers. We'll create a new mod flow simulation. Then select the first scatter point set and select the Interpolate to Mod Flow Layers command. On the left are the data sets on the scatter point set we will be interpolating from. In the middle are the mod flow arrays we can interpolate to. We can show more mod flow arrays via the toggles at the right. Notice we can interpolate to hydraulic conductivity, recharge, and CHD head arrays. The list on the bottom shows which data set will be interpolated to which mod flow array. GMS tries to automatically set up this list based on the names of the data sets. We can change this list manually by selecting items and using the map and unmap buttons. We can change the interpolation options by clicking the Interpolation Options button. When we click OK, GMS performs the interpolation. Let's look at some of the other rows of the grid and look at the grid in 3D. Now we will interpolate from another set of scatter points which model a pinch out. We can see there is a problem on the right side of the model, in that the bottom of layer 2 rises above the bottom of layer 1. To fix the problem, we can try different interpolation options or change our scatter point data. But in many cases, GMS can fix the problems automatically via the model checker. When we run the model checker, GMS shows some errors that it found in our simulation, including layer errors. To fix the layer errors, we click the Fix Layer Errors button. We'll try the average method with a minimum thickness of 0.1 foot. The overlap is now fixed, and the cells in layer 2 on the right have been set to the minimum thickness. Interpolating the next scatter point set shows a situation where the top layer exists on the left but not on the right. In this case, we want to preserve the top elevations, which represent the true ground level. We will also inactivate thin cells so we don't have problems with dry cells. Before looking at the next case, we will reactivate all the cells. The last case represents a scenario where layers are truncated by bedrock on the sides of the model. By selecting the Truncate to Bedrock option and then the Fix Affected Layers button, each layer is modified to remain within the bedrock.